speaker for today. So welcome to Windows 7. The topic for the webcast today is new possibilities. We'll be discussing three main topics today, and those topics are graphics, the Windows Touch, the new Windows Touch which has been introduced in Windows 7 with new technological improvements other than Windows Vista. So, and the last topic would be handwriting recognition. What are the basic features that uh, has been upgraded from Windows Vista and Windows 7? We'll be discussing about that. So, I'll be starting with graphics. So, one of the areas of any release of Windows that receives a significant amount of testing and scrutiny is the performance of graphics. Desktop graphics all the way to the most extreme, CAD and Sync and the game graphics. The amazing breadth of hardware supported for Windows and the broad spectrum of usage scenarios contributes to a vibrant ecosystem with many different goals, from just the basics to the highest frame rates on multiple monitors possible. So, here we go. We set out to improve the real-world performance of graphics as well as continue to improve the most extreme elements of graphics. This is the work we do in Windows 7 and work our partners do as they work to improve the undefined hardware-software combination through drivers. So, as a note, Windows Vista drivers continue to work as it did in Windows Vista, but we have also been working with partners on updated drivers for Windows 7, which many of you have been testing through Windows Update downloads. So, if you have gone online to check out or purchase a new PC, you must have noticed that faster graphics and greater performance are always some of the key selling points. People have come to expect faster systems which enable them to edit photos, do email, watch high-definition videos, and play the latest 3D games, all with greater ease, often shuffling between these tasks seamlessly. Quite a few of these users refer to the enthusiast community, blogs, and various review sites which run the graphics benchmarks and report results evaluating how fast the graphics of the new hardware or software perform. Traditionally, graphics performance has been measured and analyzed through 3D games, but it also impacts what we call the desktop scenarios, such as when you're using the Windows UI, moving or maximizing windows, or scrolling within Word or IE, etc. The performance requirements for these desktop scenarios are quite different from 3D games. In fact, this is the reason in Windows Vista Experience Index, the Win EI, we give you a rating for these two scenarios separately, highlighted in the image below. See, the graphics and the gaming graphics are quite different. Okay, I'm getting a question here. Okay, you have so many doubts in Windows 7. Could please give me. Okay, Pratap, I guess you were in my last webcast, and I'm the same speaker. I gave you my email address. If you didn't get it, then I'll mail you again. So I'm continuing with the webcast. So graphics performance is usually accessed through many benchmarks. These can be classified into two broad categories, that is the scenario benchmarks and the synthetic benchmarks. The scenario benchmarks, these are the reports on performance of particular scenarios, that is the frame rate when flying over a terrain in a flight simulator. Many of the popular games have inbuilt benchmarking modes that demonstrate how fast the graphics performance in scenes that are typically for that game. The synthetic benchmarks are the highlights of the performance of a particular aspect of graphics, such as the ability to draw a number of lines as fast as possible. However, these are the plenty of things that we all do on our PCs that don't have benchmarks tracking them, that are still quite critical to make fast. In these cases, we use instrumentation within Windows to obtain timing information and then analyze the performance. So I'll now talk about desktop responsiveness. Okay, I'm having a question again. So you can contact me on this email address I have given you again, and this is my personal email. You can please contact me on that. If you have sent a mail and you haven't got a reply, this might be because your mail landed up in my spam folder. So you can please contact me on the address I just gave you. You will hear from me. And please carry on with the webcast session. So many have experienced scenarios where an application or Windows itself stops responding momentarily. This is a type of a performance issue that can be impacted significantly by the performance of graphics in the PC. So we categorize these as desktop responsiveness issues. Improving responsiveness both in real terms and by avoiding non-responsive moments is one of the key ways that performance is improved in the system. It is also hard to measure. Measuring depth of responsiveness is a hard problem since a number of issues which affect responsiveness aren't easily reproducible, and there is a great variety of them. They are rarely caught by either kind of benchmark, as these issues are dependent on real-world combination of factors. For Windows 7, we spent a great deal of time looking for these performance glitches using a mechanism in test version of Windows 7, which has the ability to record key OS events and when they occur. During real-world testing, when we encounter responsiveness problem, the tester can hit a record key and enter a small description of the issue encountered. The event history with diagnostic information called a performance trace is written out to a file and uploaded to a server where a team of performance analysts pass the data to figure out the cause of the responsiveness issue. This process has been successful to the extent that today most responsiveness issues can be quickly tracked down and root caused. You can, you are not getting the voice. Okay, I would just get back to you. If you're not getting the voice, you're not getting the voice. Pratap, in Windows 7, we have gone to a maximum of 7.9 accurately till now. So it will be gone up in the coming time and the version of Windows. So I'll be explaining everything. So, using the methodology I just said you, we analyzed thousands of desktop responsiveness traces where the testers experienced a frozen desktop, anywhere from 100 milliseconds to several seconds. The type of issues range from an antivirus blocking disk access for all applications while updating itself on the vendor's website to an application doing network access from a UI thread. In a significant portion of these traces, we found that a GDI application is waiting on another GDI application which is experiencing slowdowns due to excessive paging activity. This was the single most frequent occurring cause of all desktop responsiveness, desktop responsiveness issues, which without this data we probably would not have assumed. Based on these investigations, we worked to improve the architecture in these two key areas, that is the GDI concurrency and the reduction of overall memory footprint of Windows. So GDI concurrency improved responsiveness when multiple applications are running. This required re-architecture of the code around GDI. GDI means graphics device interface, synchronization, objects or locks. So coming on to the reduction of overall memory footprint of Windows. Reduce the memory overhead of composition in the desktop Windows Manager, the DWM, which is the component responsible for rendering the desktop. This helps reduce overall paging activity, and thus is especially important for low memory PCs that are especially using the shared graphics memory, the onboard graphics. So the basic two of the pictures you're seeing in your slide. The first one, the upper one, is for Windows Vista, and the second one is for Windows 7. I'll explain how they work. A number of performance traces we investigated in the context of graphics responsiveness pointed us to the design of a key synchronization mechanism in GDI. The performance challenge happens because the design of GDI in Windows Vista allows only a single application to hold a system. While this seems obviously in hindsight, when this decision was originally made, the performance characteristics of different parts of the system made this optimistic implementation perfectly reasonable. So the first one is the GDI stack for Windows Vista. The second one is the GDI stack for Windows 7. I'll explain them both now. The GD application is running simultaneously via for this global lock in order to render on the screen. The application that accesses the global lock prevents other applications from rendering till it releases the global lock. The situations often get very hacky when the application that is holding the lock needs to page in a large amount of memory from the disk, since moving the memory from the disk to RAM takes a relatively long time. The picture shows you two GD applications running simultaneously contending for the global lock. If application X gets a hold of the lock, it can remember to the screen while the application Y is unable to do so and wait for the application X to finish. The solution to the problem was therefore to reduce the lock contentions and improve concurrency by re-architecturing the internal synchronization mechanism through which multiple applications can reliably render at the same time. Contentions due to the global exclusive lock is avoided by implementing a number of fine-grained locks which are not exclusive but aid parallels. The increased number of fine-grained locks add a small overhead of scenarios where only a single application is rendering at a time. Special attention was paid to GDI application compatibility, as changing internal synchronization mechanism in the most widely used APS stack could potentially give rise to timing issues such as deadlocks and rendering corruption. This work also resulted in better rendering performance of concurrent GDI applications on multi-core CPUs. The multi-core Windows PCs benefit from these changes more than one application can now be rendering at the same time. After the GTI concurrency work was implemented in Windows 7, builds leading to the beta, we saw a large reduction in the number of desktop responsiveness issues reported by our testers, which were caused by one application blocking another one due to GTI. To further validate the scalability of a new implementation, we wrote some tests. I'll show you another slide on this. Okay, you want to know the difference between the two figures, just so they can know. Okay, the first figure represents Windows Vista GDI model. So it was like an application X, like say your one application and your second application both are working in the same manner. So the first application goes to the GDI module, and it has to go to the lock mechanism. So when it tries to reach, it can reach, but the second application cannot, because it has to wait for the lock mechanism to get released. When it will get released, then only the second application can access. So when the second application gets to hold, your system gives you a temporarily kind of a hang, which was in Windows Vista. But now, as your screenshot shows you, that there is no bottleneck now. Now, multiple applications can stack with the GDA graphics stack, and then all the applications can work simultaneously. So it won't be a problem, and your system will get to have less hang-ups and less hiccups. I guess I made myself clear. Bottleneck means that your basic applications, a single application can work at a time, but without the bottleneck is that multiple applications cannot address the same GDI graphics stack at once. So when multiple applications cannot access it, only one application can access it, so it will be a temporarily hang for the second application or the third application or the fourth application. While in Windows 7, all the applications, a particular number of applications can work simultaneously. They can work concurrently, and they can gain access to the GDA graphics stacks, and hence there will be no performance issues as there was in Windows Vista. So as I was talking about the test, so without the Windows 7 GDI concurrency, the rendering throughput of these applications is effectively limited to the performance of a single CPU core. Since only a single application can acquire the global exclusive lock while the others are waiting, this scenario doesn't benefit from the multi-core CPUs. This demonstrates that GDI applications in Windows 7 are now much less dependent on one another. This benefit will not need any new display drivers. It will work on any Vista WDDM 1.0 and newer display drivers. So this is the concurrent table that works. Again, getting some questions. Okay, Vivekanand, just a second. Now you can please try to need the meeting entry code. I need to log in through the live meeting. For that, I need this meeting entry code. Just a second, I'll help you out. Pratap, do you want to ask something? You are raising your hand. If please you want to ask something, please write it in the panel. So on the desktop graphics, there is a reduced memory footprint. Another area which affects system responsiveness is memory usage. Simply put, increased system memory use which leads to an increased paging activity, which directly leads to reduced system responsiveness. Just for the best responsiveness, all applications, processes, and OS components need to use as little system memory as possible. In Windows Vista, the amount of memory required to run multiple Windows scales linearly with the number of windows opened on the system. This results in more memory pressure when there are more windows or if the monitors have higher resolution. It gets worse if you have more than one monitor. As part of investigating various means to improve system responsiveness, we saw a great opportunity in reducing the usage of system memory by DWM. In Windows Vista, every GD application Windows accounts for two memory allocations which hold identical content, one in video memory and one in system memory. DWM is responsible for composition of the desktop through the graphics hardware. Hence, it requires a copy of the same allocation in video memory, which is easily accessible by the graphics hardware. The duplicate copy present in system memory is required because GDI is being rendered utilizing the CPU completely in the operating system without any assistance or acceleration by the graphics hardware. As the CPU performs all the tasks for rendering GDI applications, it requires an easily accessible, cacheable copy of memory. I'll just show you how it works. Okay. This is the existing memory allocations in Windows Vista. So the slide you are seeing right now is the existing memory allocations which is present in Windows Vista. But what changes in Windows 7 you'll see in the next slide right here. So now the duplicate copy is gone. Right. So I'll just explain it in Windows 7 saves one copy of the memory allocation per application window by getting rid of the system memory copy entirely. Thus, for a GD application window visible on the desktop, the memory consumed is cut in half. So now the system memory allocation is not needed for the application. The duplicate copy is now gone. Only a single copy is being used. So what happens is that the video memory allocation handles the graphics and the system memory is not used. So it will just give you a better memory accuracy and your system responsiveness will be good. So it achieved the reduction in system memory by accelerating the common GD operations through the graphics hardware. The WDDM drivers accelerate these to minimize the performance impact of the CPU read back of the video memory. This was necessary as performing these operations otherwise on the CPU would incur a heavy performance penalty. In order to decide which GDA operations to accelerate, it was important to understand the usage pattern of various GDA applications. We profiled the top 100 GDA applications to learn more about their calling patterns and frequency and nature of the GDA operations. So just to be continuing up, I'll just show you the a sort of the list of the applications and the calling patterns and frequency of the GD operations. So based on the real-world application statistics, a tiny snapshot of which I have already shown you, got worked with our graphics IHV partners to provide support in their drivers to accelerate the most commonly used GDA operations. Windows 7 systems with these updated drivers called the WDDM version 1.1 will thus benefit from this memory savings work. Please note that the WDDM 1.0 drivers continue to function and are fully supported on Windows 7. You might have seen Windows updating provided these 1.1 drivers during the beta. These drivers are themselves in beta. So I'll just show you a screenshot. A pattern, the WDM memory consumption comparison. So the As you can see, the red one is the Windows Vista model, and the green one is the model which is being currently used. You can see the memory consumption is too less. It is less than 50 MB, and you can see the difference yourself. So the data shows that the memory savings become more and more pronounced when you have multiple applications windows visible on the desktop. Since you have seen a lot of system memory, the paging activity gets reduced. As a result, your system responsiveness improves for the same workload. Certain trade-offs have to be made for the desktop responsiveness improvements, which benefit a wide range of systems. For example, the elimination of a duplicate system memory copies, which speed up certain operations, introduce slightly reduced performance, as the CPU now has to read data back from the video memory. An analysis of the real-world application statistics shows that these operations were rare. However, certain GDI micro benchmarks which issues these operations show some performance degradation. This is something to note if you are running existing benchmarks that stress specific GDI operations repeatedly, which isn't necessarily a reflection of a real-world performance. So, getting to the point is Windows 7 is being much responsive overall. The improvements overall are definitely noticeable on memory constrained PCs with shared memory graphics. That is the onboard graphics we all use, many of us use. So, from the desktop graphics, I'll come on the gaming graphics. So the gaming graphics is a key part for many of us. So there are a number of popular benchmarks such as 3D Mark as well as in-game benchmarks, which are really a mode in which you can run your game, where it renders the game scenes and animations without any user interaction. This area has been well tracked by the gaming industry through various industry benchmarks, which are pretty realistic and representative of actual games. The different benchmarks and tests are widely discussed, and gamers all well versed in the subnetics of these measurements and translating them into the recommendations depending on the hardware drivers and gaming expectations. For Windows 7, we work closely with the graphic partners, helping them improve the WDDM drivers, giving a performance with specific changes to how Windows 7 works under the hood, which while maintaining the same driver model and compatibility. The continued investments in performance tools has helped us and our IHV partners track down and analyze various gaming performance bottlenecks and fix them in subsequent driver releases. The fundamentals of the Windows display driver model remain unchanged in Windows 7. Some policies around GPU scheduling and memory management were changed to enable better performance in certain scenarios. Because these benchmarks are very sensitive to the specific hardware, firmware drivers, and overall system, because these are so widely measured and discussed elsewhere. So, as you see, now we have worked hard to improve the architecture for graphics for real-world performance. In this, it benefits both ends of the hardware spectrum by enabling low physical memory systems to run leaner or faster Windows, and at the same time enabling multi-core CPUs render multiple graphics applications much more efficiently. Okay, what is the difference between WDDM V1 and V1.1? As I just told you that you can see the screenshot. The red bars represent WDDM version 1 and the green one is 1.1. The chart shows you that the number of applications are open, the number of windows are open, and how many megabytes of memory are they having. So in Windows Vista, the memory usage as the windows open, like say you have 50 windows open, so it will get you around 350 megabytes. The current V1.1 model will get you will take away about 350 megabytes of memory. While in Windows 7, by using the WDDM version 1.1, the usage of memory is less than 50 MB for how many windows you can open. Like you open 50 windows, then also the usage of the memory is under 50 MB, so it gets your Windows free. Your Windows is having to use less memory, so providing your memory to the heavier applications you might use. The more heavy applications you use, the more your memory will get used. So by the WDDM 1.1 model, it is basically used to give you a better performance while gaming or while desktop performance. This is the basic difference, as you can see the chart. So as now continuing, so we'll talk about the Windows Touch technology now. We'll get a hype on what exactly is being better from Windows Vista in Windows 7 with the touch technology going on. So for Windows 7, touch support is by building on the advances in the input technology. We began with the tablet PC's work on Windows XP. Touch in Windows 7 requires improvements in hardware, driver software, core Windows user experience, and of course application support. By having this support in an open platform, consumers and developers will benefit from a wide variety of choices in hardware, software, and different PC form factors. Quite a few folks have been a little skeptical of touch, often commenting about having fingerprints on their monitors or something along those lines. We think touch will become broadly available as the hardware evolves, and while it might be the primary input for some form factors, such as well as the mounted displays in a hospital, kiosks, or a point of sale, it will also prove to richly augment many scenarios, such as reading on a convertible laptop or a kitchen PC. So Windows Touch is designed to enhance how you interact with a PC. For those of us that have been living and breathing touch for the last 2 years, we are excited to be able to deliver the capability to people using Windows 7. So making Windows touchable. With Windows 7, we have enriched the Windows experience with touch, making touch a first-class way to interact with the PC alongside the mouse and the keyboard. We focus on common activities and refine them thoughtfully with touch in mind. You will have the freedom of direct interaction, like being able to reach out and slowly scroll a web page, then click quickly to move through it. With new touch-optimized applications from creative software developers, you will be able to use and immerse yourself as you explore your photos, browse the globe, or go after bad guys in your favorite games. While providing this touchable experience, we made sure that you are getting the full Windows 7 experience and not a subset just for touch. We've been asked if we are creating a new touch UI or touch shell for Windows, something like Media Center that completely replaces the UI of Windows with a version that is optimized for touch. As you can see from the data, we are focused on bringing touch through the Windows experience and delivering the optimized touch interface where appropriate. A touch shell for launching only touch-specific applications would not meet customer needs. There would be too much switching between touch mode and the Windows application. Instead, we focused our efforts on augmenting the overall experience so that Windows works great with touch. the approaches which have been taken, some broad and some very targeted to support this goal, like the touch gestures. Windows 7 has a simple set of touch gestures that work in many existing applications. These include the basic of tap and drag, as well as scroll, right click, back, forward, zoom, and rotate. More details on how gestures work in described. So, uh, improved high DPI support. Windows 7 has improved high DPI support. The broad benefit to touch is that the UI elements are rendered closer to the intended size, usually larger, which makes small buttons, links, and other targets easier to access with touch. Um, I'm working in AMD testing graphic card, so I need to learn more about the Win 7 graphics functionality. Okay, you need to learn more about the Windows 7 graphics functionality. I'll provide you with some links. Please email me, and I'll get back to you with all the links you might need on the graphics technology improved in Windows 7 from Windows Vista. I hope that solves your problem. So the third one is the improved window management. The updated taskbar and Windows arranging features go a long way towards making Windows easier to use with touch. There have been several subtle but critical touch optimizations. The taskbar buttons and thumbnails are ideally sized for pressing with touch, and specific behaviors are turned for touch input. For example, the jump list can be accessed with a simple drag up from the taskbar and then opened with touch, and the shortcuts in the jump list are drawn with extra vertical spacing to make them easier to select. Arrow peak has been turned to work with touch. The show desktop button is twice as wide. The only visual sign the only visual sign you are on Windows Touch PC. And instead of hovering, which you can't do with touch, a press and hold on the button activates arrow peak. Sizing and positioning windows is easy with arrow snap. Just a drag a window to a screen edge. Furthermore, this was turned with spatial touch threshold so that you don't have to drag to the affiliate edge of the screen. A better balance for touch usage. The refinement to key experience. Desktop browsing and media activities were refined to provide an optimized touch experience. Internet Explorer 8 includes support for the core touch gestures, scrolling back, forward, zoom, as well as an optimized address bar that opens by dragging down, and extra spacing in favorites and history lists when opened with touch for easy selection. In Windows Media Player, the transparent controls, play, pause, etc. have larger clickable areas even though they still look the same size, so that they are easier to touch. The touch keyboard. The on-screen touch keyboard has been optimized for touch with glow key. Feedback that's visible when your finger is covering the letter, and multi-touch support for natural typing behavior and key combinations. It's designed for quick usage, like entering a URL. Overall, the Windows touch features are designed to work together to deliver a great end-to-end touch experience. For example, the goal with IE8 was to deliver a seamless touch browsing experience. This includes the panning, zooming URL entry, and several interface enhancements. So I'll come to the gestures part. The Windows touch gestures are the basic actions you use to interact with Windows or an application using touch. So the basic mantra with the gestures has been predictable, trust, reliable, equal to habit. To be predictable, the action should relate to the results. If you drag content down, the content should move down. To be reliable, the gestures should do roughly the same action every day. And the gestures need to be responsive and robust to reasonable variations. If these conditions are met, then people are far more likely to develop habits and use gestures without consciously thinking about it. So tap and double tap, touch and release to click. This is the most basic touch action. Can also double tap to open files and folders. Tolerance are turned to be larger than with a mouse. This works everywhere. Drag, touch and slide your finger on screen like a dragging with a mouse. This moves icons around the desktop, moves windows, lifts text by dragging left or right, etc. This works everywhere. Scroll, drag up or drag down on the content of scrollable windows to scroll. This may sound basic, but it is the most used and most useful. It's a lot easier than targeting the scroll bar. Gestures in the beta, according to our telemetry, you'll notice details that makes this is more than natural interaction. Zoom. Pinch two fingers together or apart to zoom in or out on a document. This comes in handy when looking at the photos or reading documents on small laptops. This works in an application that supports mouse while zooming. The two-finger tap. Tapping with two fingers simultaneously zooms in about the center of the gesture or restores to the default zoom. Great for zooming in on hyperlinks. Our applications need to add code to support this. The rotate. Press two spots on a digital photo and twist to rotate it. It's just like a real photo. Application needs to add code to support this. Flicks. The flick left or right to navigate back and forward in a browser and other applications. This works in most applications that support back and forward. Press and hold. Hold your finger on the screen for a moment and release after the animation to get a right click. This works everywhere. As you can see, okay, I'm getting one question. So as you can see in the screenshot, uh, the analysis which has been showed that many short gestures were going unrecognized. The gesture recognition heuristics needed to see 100 ms or 5 mm worth of data before making a decision about what gestures the user was performing. The concern that originally led to these limits was that making a decision about which gesture was being performed too early would lead to misrecognition. In fact, when we looked at the collected user data, we found we could remove those limits entirely. The gesture recognition heuristics performed very well in the ambiguous situation. After applying the change and replaying the collected gestures sample data, we found zoom and rotate detection improved by about 6% each, and short scrolling improved by almost 20%. The supporting gestures. Gestures are built into the system in such a way that many applications that have no awareness to touch respond appropriately. We have done this by creating default handlers that simulate the mouse or mouse wheel. Generally, this gives a very good experience. But there are applications where some gestures don't work smoothly or at all. In these cases, the applications needs to respond to the gestures messages directly. In Windows, several experiences have been gesture enabled. We spent a considerable amount of effort on IE8, ensuring scrolling and zooming are smooth and that the back and forward are at your fingertips. So a major benefit of Windows ecosystem is diversity. PCs come in all shapes and sizes. To help ensure that is a great Windows Touch experience across the many different types of PCs, we have defined a set of measurements and tests for Windows Touch and that are part of Windows logo. We have been working with Touch hardware partners since the beginning of Windows 7 to define the requirements and ensure they are ready for launch. Our approach has been to provide an abstraction of the underlying hardware technology. We specify the requirement for the quantitative aspects of the device, such as accuracy, sample rate, and resolution, based on the requirements to successfully enable touch features. For example, we've determined the necessary accuracy values for a device so people can successfully target common UI elements like close boxes, or what sample rates and resolutions are required to ensure quality gesture recognition. The requirements are from the basis from the Windows Touch logo program. For consumers, the logo tells you that the PCs and all of its components are optimized for Windows component level logo, which is what we grant to touch digitizers. Helps the OEM choose a device that will deliver a great touch experience. Based on the quantitative requirements, we built an interactive test suite that includes 43 separate tests, all validating the core requirements under different conditions. There are single-point accuracy tests at various locations on the screen, including the corners, which are often harder for accuracy but critical to Windows. There are also several dynamic tests where accuracy is measured while drawing lines on the screen. See the screenshot that is below. Yeah, Pratap, in Windows 7 we have the touch screen feature. I'm just actually explaining that only. How the touch is being better in Windows 7. So, so not all devices pass the test. Now, passing line accuracy test from Windows 7 Touch logo from the test tool which you're seeing here. So, what is with the Windows Touch for software developers? We also want to talk a little about the touch platform for software developers. Windows 7 provides a rich platform for applications. We've already mentioned gestures. There are also a lower level platform that gives developers complete control over the touch experience. We think about it in a good, better, best software stack. The good. The good bucket is what touch unaware applications get for free from Windows 7. Windows 7 provides default behavior for many gestures and will trigger those behaviors in your applications in response to the user input. For example, if someone tries to touch scrolling over a window that is a touch unaware, we can detect the presence of the various types of scroll bars and will scroll them. Similarly, when the users zoom, we inject messages that provide an approximation of the zoom gesture in many applications. As a developer, you can ensure that the default gestures work just by using the standard scroll bars and responding to control mouse wheel messages. The better. The better bucket is focused on adding direct gesture support to the small application behaviors and UI changes to make applications more touch-friendly. For instance, there is a new Windows 32 Windows message that informs the application gestures was performed over its window. Each message contains information about the gesture, such as how far the user is scrolling or zooming when the center of the and where the center of the gesture is. So Windows 7 is designed to provide efficient ways to use multi-touch for the most common and important scenarios, while being a natural and intuitive complement to the mouse and keyboard people use today. I'll be coming to the recognizing improvements in Windows 7 handwriting. So Microsoft has been working on handwriting recognition for over 15 years, going back to the pen extension for Windows 3.0. With the increased integration and broad availability of the handwriting components present in Windows Vista, we continue to see increased use of handwriting with Windows PCs. We see many customers using handwriting across a wide variety of applications, including school, hospitals, banking, insurance, government, and more. It is exciting to see this natural form of interaction used in new scenarios. Of course, one thing we need to continue to do is improve the quality of recognition as well as the availability of recognizers in more languages around the world. So Microsoft has invested in pen-based computing since the early 1990s. And with the release of Windows Vista, handwriting recognizers are available for 12 languages, including USA, UK, German, French, Spanish, Italian, Dutch, Brazilian, Portuguese, and Chinese, simplified and traditional, Japanese and Korean. Customers frequently ask us when we plan to ship more languages and why a specific language is not yet supported. We are planning to ship new and improved languages for Windows 7, including of Norwegian, Swedish, Finnish, Danish, Russian, and Polish. And the list continues to grow. Windows has true cursive handwriting recognition. You don't need to learn to write in a special way. In fact, we are taught or trained as we say. Windows, the handwriting styles of thousands of people, and Windows learns more about your style as you use it. Over the last 16 years, Microsoft has developed powerful engines for recognizing handwriting. They continue to tune these to make them more accurate, faster, and to add new capabilities, such as the ability to learn from you in Vista. Supporting a new language is much more than adding new dictionaries. Each new language is a major mental investment. It starts with collecting native handwriting. Next, we analyze the data and go through iterations of training and tuning, and finally the system gets you to continue to improve as you use it. So I'll say that if during this webcast you have any questions, you can use the Q&A panel at the top of your window to ask the question, and I'll get back to you. So the data collection part. The development of a new handwriting recognizer starts with a huge data collection effort. We collect millions of words and characters of written text from the tens of thousands of writers from all around the world. So before I describe that collection efforts, I would like to answer a question we are frequently asked. Why can't you just use an existing recognizer with a new dictionary? One reason is that some languages have special characters or accents. But the overriding reason is because people in different regions of the world learn to write in different ways. Even between countries with the same language, like the UK and the US, the characters that may look visually very similar to you can actually be quite different to the computer. This is why we need to collect real-world data and capture exactly how characters, punctuation marks, and the other shapes are written. Setting up a data collection effort is challenging and time-consuming because we want to ensure that we collect the right kind of data. We carefully choose our collection labs in the respective countries for which we develop recognizers. Before we start our data collection in the labs, we configure our collection tools, prepare documentation, and compile language scripts that will guide our volunteers through the collection process. Our scripts are carefully prepared by native speakers in the respective language to ensure that we collect only the correct data from different writing styles, and the data covers all characters, numbers, symbols, and signs that are relevant to a specific language. All of our scripts are proofreaded and edited before they're blessed to be used at the collection labs. Once the tools and scripts are ready, we open our labs and start to recruit volunteers to donate their handwriting samples. Our recruitment efforts ensure that we have balanced demographics and such as gender, age, left-handedness, and educational backgrounds that represents the majority of the population for that country. So this is what the collection tools looks like. Like you can see here, the following word or phrase. As soon as you make the plan, like you write it on the writing pad. So a collection session lasts between 60 to 90 minutes, at which point a volunteer has donated a significant amount of handwritten data without being fatigued. So this is the ink sample illustrations, different strokes orders, like you can see in the screenshot. And how question again? Sanjeev, Windows 7 is for computers. Windows Mobile 6.1 was out in the market some time back, and Windows Mobile device is a completely different platform from Windows 7. So I'm sure that Windows Mobile team is on a new Windows OS for us. They might be on a new Windows OS for us, but I'm not sure about that. We are just here today for Windows 7 for desktop, laptop, PCs. So I'll answer your question. We can only say about Windows 7 here for desktop, laptop, and other types of PCs. So how the improving the recognizers through personalization? The training that is done to teach the recognizer a personal writing style is the same training that happens before Microsoft ships the product. The only difference is that we are now collecting unique training data from the specific person and not that of thousands of people. We call this process personalization. As you can see in the screenshot, this is the personalization result, the sentence mode. As the screenshot of the personalization result illustrates, a person is asked to write the requested sentence to provide his/her ink samples. The more data a person donates during the personalization process, the better the recognizer will become. In addition to providing writing samples based on specified sentences, a person can target specific recognition errors, shapes, and characters that will be used for training. The personalization features is complex and offers a variety of different modules that enable a person to optimally tune the recognizer. We are very proud to announce that the personalization will be available for all Vista languages and all new Windows 7 languages. We encourage you to use this feature to improve your recognition accuracy. So, what if there is a handwriting error? This is the error recognition. This screenshot shows you that if you make a mistake while typing, you can also use the I'm sorry, I'll just take a water break. Thank you. So, with report handwriting recognition errors, people can choose which of the misrecognized ink samples they want to submit. So, this is where I conclude my webcast session today. I'll be taking your questions now. If you have any questions in any regard in Windows 7, not for only the topics included today, but for my last two webcasts other than this, or any topics you might think are for your Windows 7, or Windows Vista, you can ask any type of questions today. I'll be waiting 5 minutes for any kind of a questions which I get. By concluding, I would say that thank you all for taking the webcast session today. and we hope that you will be joining us on the further webcast sessions if we have any. You will be notified by emails, or you can check back the Windows webcast series. Better, okay, I'm getting a question. Perhaps you don't need to raise your hand. I'm getting your questions like that. Okay, better device management means you are talking about the last webcast, I guess. So better device management means you can please have your question a bit rephrased if you can. What basically are you talking about? Means the better device management in Windows 7. If you could please rephrase your question. Are you talking about a single device, or you're talking about the multiple hardware management I told in the last webcast? The last webinar. Okay. So the device management basically is a kind of a new device manager which is been introduced in Windows 7. It gives you better options to install your hardware, to maintain your hardware, and it gives you all the options related to the hardware in a new UI look. Like you click on I actually provided on-screen instruction by sharing my desktop, which I cannot do today, but in simple words, I'll say that the new device management features gives you excessive usage over your hardware that you didn't have in the previous version of Windows. It gives you and equals your own relying on your hardware, your own control over your hardware. So you can control your hardware as you like it. It is presented just in the start menu. You can click on the start button and you can click on devices and printers. What exactly can you get from your device? It has been shown there. I hope I answered you okay. Any more questions? I'll be happy to answer them. I'll wait 2 more minutes for any kind of questions you might be having. Okay, Pratap, the major changes added in the new taskbar is the frequency of the programs you use. The jump lists. The jump lists are like just if you're using Windows 7, a right click on the taskbar on any icons. Like say you right click on the Internet Explorer icon. What happens is that a jump list gets up. It shows you what basic applications and the basic websites you use the most. If you
Please pardon the interruption. Your conference contains less than 3 participants at this time. If you would like to continue, press star 1 now, or the conference will be terminated.
So you right click on it and you see a jump list. The jump list gives you the basic idea of what you use the most. The most frequent folders you use, the Windows Explorer, or in Media Player, what exactly did you play, the frequent usages. So you will get what you want from the jump list. Then your taskbar is really simplified. It's simplified in the sense that all the programs you open are stacked within their respective properties. So you don't have to go around and search for each and every tab that opens up in the taskbar. You can just go to like say you have opened up to 50 of Internet Explorers. So you can just click on the ID icon, and all these will be in a list, like a list, like uh, but not like it is tagged in your taskbar in about 100 of for the 50 windows. So your taskbar is now clean. I hope that answers my question. So this concludes my webcast session today. Thank you all for joining in, and I hope you like the session. And thank you all for joining. Shantanu.
Is now exiting.